We are given that the cosine of theta is 1/2 and that the cosecant of theta is negative. So the first thing we need to do is figure out, I need to draw a triangle and I need to figure out what quadrant to draw my triangle in. So the very first thing I'm going to do is the Astc chart. So even though it doesn't tell me that cosine is positive or negative, it tells me that it's 1/2 and I can tell that that's a positive number. So the first thing I'm going to do is figure out which quadrants is cosine positive in. And that would be in quadrant 1 and quadrant 4, because the A stands for everything being positive and the C stands for cosine being positive. Now we need to figure out where is cosecant negative, because that's what this less than 0 is talking about. So first I need to think, where would cosecant be positive? And I think it's a little bit easier, instead of thinking about it as cosecant, to think about it as its reciprocal, which is sine. So let's think about, where is sine positive? Well, sine would be positive in quadrant 1, where everything's positive, and it would also be positive in quadrant 2, where there's an S, because that's what the S stands for, is for sine being positive. But since I want to know where it's negative, I'm actually going to put a box around the other 2. So now you can see that I have 2 marks in quadrant 4. That means that when I actually draw my triangle, I'm going to draw it in quadrant 4. So I'm going to draw a right triangle and put my right angle there, and theta always goes up by the origin. And now I can actually start doing something with my numbers. So I'm going to label the 3 sides of my triangle. The side that's along the x-axis is always labeled x. The vertical side is always y, and then the hypotenuse will always be r. Hopefully you have your ratios memorized. The cosine of theta is always equal to x over r. So since it told us that it was equal to 1/2, I now know that x is 1 and r is 2. So I'm going to label that on my triangle. X is 1 and r is 2. I now need to figure out what y is. And in order to do that, I'm going to use the Pythagorean theorem. So I'm going to use x squared plus y squared equals r squared. I now know that x is 1, y I still don't know, and r is 2. So 1 squared is 1, 2 squared is 4. If I subtract 1 from both sides, I get that y squared is equal to 3. And then if I take the square root of both sides, I get that y is equal to the square root of 3. Now there's one thing we have to pay attention to. Because we are in quadrant 4, I'm going to have some negative values. Now r is always going to be positive, but x and y can be positive or negative. So if you think about this point right here on the triangle, if I had to get to that point, I would have to go right 1 and down 3. Down the square root of 3. So since I had to go down to get to that point, this value right here, the square root of 3, actually has to be negative. So when you do the Pythagorean theorem, you're always going to come out with a positive answer, but then you have to look at your triangle and decide, did I go in a negative direction? And a negative direction would be either going left or down to get to your point. All right, so let's take a look here now at our problem here. Oh, and I just realized I didn't write down that we're in quadrant 4. We figured that out from this little chart up here. Okay, so I'm going to go through and write down all my ratios, which hopefully you have memorized. So I'm going to write down y over r, x over r, y over x, and then r over y, r over x, x over y. All right, so let's start with sine. Sine is y over r. Y is the negative square root of 3, and r is 2. So that would be my answer for sine. Let's go through and do cosecant, because all I have to do to find that answer is to flip our fraction. So that's going to be negative 2 over the square root of 3. And I'm going to put a little star next to this one because that one has a radical in the denominator. So we'll come back to that and rationalize in just a minute. Cosine was given to us, so we don't have to do any work to get cosine. And then secant, if I take 2 over 1 and I flip it upside down, if I take 1/2 and flip it upside down, it gives me 2 over 1. But I don't have to write the 1, so I can just write it as 2. And then for tangent, it's y over x. So y is negative square root of 3. X is 1. So I could actually just write it as the negative square root of 3. I don't have to keep the 1 there. And then for cotangent, I would flip it. So that would be negative 1 over the square root of 3. So that one also gets a star because we're going to have to come back and rationalize. All right, so let's go back to cosecant. In order to rationalize, we're going to multiply by the square root of 3 over the square root of 3. And then when I multiply straight across, which I'm actually going to do up above it because I'm running out of room, if I multiply straight across, I would have negative 2 square root 3, and then my denominator would be 3. So this would be my final answer for cosecant. And then for cotangent, we're going to do the same thing. We're going to multiply by the square root of 3 over itself. And I'm going to write this underneath. If I multiply straight across, I have negative 1 times the square root of 3. I don't have to write the 1, so I'm just going to write the negative square root of 3, and then my denominator would just turn into a regular 3. So that would be all 6 of my trig functions.